All right, so let's go through this simplifying algebraic expressions ACT packet, and hopefully we can get some questions answered here. It's going to be a little bit more difficult, so you notice there's not as many questions on this packet as, say, like your mean, median, and mode, which is a lot of basic stuff that we should know. This is actually going to move us over to some Algebra 2 content. So I'm going to go around the room and ask what you got, and stop me if you have a question or you got it wrong and you need a question explained. Question number 1 for variables a and b, x equals 5a squared and y equals negative 2a cubed plus b. Which of the following expressions represents the product x, y? Liz, what did you get for that answer? J. Negative 10a to the 5th plus 5a squared b. Haley, you want to see that one worked out? Okay. What's that? What's wrong?
Is that wrong or
No, J is correct. J is correct. J is what you want to get. So for variables a and b, we get this. But it says, which of the following expressions represents the product x, y? So actually what you want to do is you want to take 5a squared times negative 2a cubed plus b. Okay, so we're just going to distribute. And so I'm going to go ahead and finish this out for the sake of, we're recording. So we're distributing there, so we're going to end up with negative 10a to the 5th, right? Because we're going to add our exponents. So we're adding 2 plus 3.
Yeah, I thought parentheses. I thought if it's outside the parentheses, it multiplies. Yeah.
It's still just multiplication, so we still just add our exponents.
Does it only multiply whenever it's an exponent to the parentheses then?
Well,
Like if it's negative 2a cubed plus b squared.
Okay, so you're saying if this was a b squared over here?
Like the square was outside.
Oh, if the square was here, okay? Okay, that's when I would multiply, because that is what we call the power rule of exponents, which means I'm taking an exponent to an exponent. This would give me negative 2a to the 6th plus b squared.
Oh, that's what I thought was going to do that.
Yeah, but it's attached to this, so I'm not squaring what's inside the parentheses. I'm squaring the a. All right, so we're going to continue on here. I'm kind of glad we are finishing this. All right, so the rest of this, because there's technically a 1 here, is plus 5a squared b, right, which is what we see right there. Right, there's no exponents to add there because I don't have like terms. Okay, does that make a little bit more sense now? Great. Okay. Well, let's come down to question number 2. Zamira, what did you get on question number 2? J. All right. Now this is one I kind of expected that there might be some questions on. Is this one that needs to be covered, or do we feel pretty comfortable with it? Okay, this is where we're talking about, we've got an unknown price, we've got a coupon, we're doubling that coupon, and then we're trying to find out what the price would be per ounce after the coupon has been doubled. So do we understand where we're getting J from? You understand? Okay, and nobody else needs that explained? Okay, all right, we'll move on then. Number 3. Number 3, Haley, what'd you get for number 3?
8x minus 1.
Okay, no. So I'm guessing this is one we want to look at. All right. In 6 games, Bill scored X points in each of the first 3 games, X minus 3 points in each of the next 2 games, and 3X plus 2 in the 6th game alone. Which of the following expressions best represents the total number of points Bill scored in all 6 games? So we could do this as an expanded expression. All right. So let's start off with this. First game, how many points did he score? No, look. X. So X. And in game 2, he scored how much? No, look. In 6 games, Bill scored X points in each of the first 3 games. So how many points did he score in the second game? X. How many points did he score in the third game? X. Okay? In each game, he scored X points. okay, for the first 3 games. All right, then let's see. Let's look in the next, in the 4th game, how much did he score? Look, x minus 3 points in the next 2 games. How many points did he score in the 4th game? X minus 3. Okay. How many points did he score in the, we're at 1, 2, 3, 4, in the 5th game? X minus 3. Okay. And in the 6th game? 3x plus 2. Right. Now I could have consolidated this as I went, but I want you to see this as game 1, game 2, game 3, game 4, game 5, game 6. All right. Now what do I want to do with all of this? Combine like terms. So of my x's, I've got 1, 2, 3, 4, 5, 8, right? I've got 8x, which you got. You got the 8x part, right? Okay. Now let's see where we're getting the rest of this from. Let's combine. I've got negative 3 plus negative 3. What's that? Negative 6. All right, negative 6 and negative 6 plus 2, negative 4. So the algebraic expression of how many points he scored over 6 games is 8x minus 4. So long as I knew what x was, then I could find out exactly how many points he actually did score, right? Okay, does that make a little bit more sense now? Okay. When they give you a sequence like that, sometimes it's best just to leave it expanded. Okay. All right, let's look at question number 4. Dylan. 16 is correct. Any questions on number 4? Yes? You want to see it? Well, let's just look. How many zeros are there in the integer representation of the product of 2 million and 5 billion? All right, so product means what? Multiplication. Okay, so I've got 5 billion. 1, 2, 3, 4, 5, 6, 7, 8, 9. I believe that's going to be my billion times 2 million. Okay, so 2 million. Okay. How many zeros, what am I going to get whenever I multiply that set of zeros? Am I going to basically add the zeros, right? Okay, so it looks like I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, but because I'm 5 times 2, right? What's 5 times 2? 10, right? Which gives me that extra 0 there, which is why I'm getting 16 zeros. Yep, product. Okay, that's why we get 16. All right, flipping my page over, let's look at question number 5. Ryan, what did you get here? F. F is correct. Questions? None. Okay. Go ahead. Negative 4a plus 2b.
Yeah, but whenever you're finding the average, that you want to add all of the numbers and then divide it by 4.
If n equals negative 3a and m equals 2b minus a. Okay, yeah, I was going to say average. I don't think we're needing to find the average there. We're just adding. Okay, so combination of like terms. Right? Okay. All right. Number 6. Marcus, did you get this far? Yeah. Okay, what did you get for 6? K is correct. Anybody need to see that work? Okay, no? All right, let's see. Now, I know this one is a repeat from yesterday. This question showed up twice. But let's just see how you do with it. Number 7, JP, what did you get there? You got B. No. All right. This one's, this kind of goes back to that greatest common factor. Okay, or sorry, yeah, greatest common factor. So we're looking at a number that will go into 75 and 90, but doesn't go into either 18 or 10, but we want to add up the digits in it. So it's got to be at least a 2-digit number if I'm going to add up the digits that are in it, right? So what's a number that will go into 75 and 90, but won't go into 18 or 10? Okay, well, let's start. We know it's a 2-digit number because I have to add the digits up, right? So we've got to start at least there. And obviously it can't be a 3-digit number because it can't fit into it, correct? All right, so let's start with the smallest 2-digit number is what? 10. Will 10 go into 75? No, okay? Let's go to 11. Will it go into 75? 12, 13, 14, 15. Okay, will 15 go into 90? Okay, but we don't want 15 to go into 18 or 10. Will 15 go into 18? No. Okay, and obviously it won't go into 10. So we know that 15 will work for this. Okay, what happens or what do I get whenever I add up the digits in 15? What's 1 plus 5? 6. Yeah, like I said, it's a tricky question, and even though it was on the assignment that was due yesterday, I wanted to cover it again today because 1, we got a bunch of people who weren't here yesterday, and 2, maybe we didn't understand it yesterday as well as we thought. Okay? All right. All right, let's keep moving here. We're getting into linear inequalities, and this is a good section to get into because a lot of stuff here gets forgotten. Let's see, where am I at? Vanessa, number 1. What'd you say? B, no. Which of the following shows the solution for the inequality? 5x minus 1 is greater than or equal to 9, okay? So what we're trying to do here is we're trying to solve for x. And we're going to solve for x the exact same way through most of this that we would as if there was just an equal sign there, okay? So in solving for x, I need to isolate x. What's the first thing I want to move to the right-hand side? The -1. How do I move -1 to the right? Add it to both sides. Very good. All right, so I'm going to get 5x is greater than or equal to 10. Okay, I still want to isolate x. I need to get rid of the 5. How do I do that? Divide by 5 on both sides. So I'm getting x, and I'm going to keep my inequality going the same direction because I haven't divided by a negative, right? And I haven't multiplied by a negative. What's 10 divided by 5? 2. All right, so what we're seeing is that x is greater than or equal to 2. So 1, we want to find a place where 2 is circled, and we also, because it is equal to, is it going to be open or filled in? Should be filled in. And what's really nice is whenever I have my variable on the left-hand side, the inequality will point to the direction that my arrow is going to go, right? So that's what's handy about that. If I notice that it is pointing to the right, I should be going to the right. So that's filled in, and I'm going to the right, okay? Does that make a little bit more sense than it did before? Okay, okay. So our answer should be A, okay? All right, let's keep going here. Let's come back to Liz for number 2. What'd you get? Yep. J? No. No. All right, and you're close on J. It's, what should it be? It should be H, right? Because if we go back up to our top and we look, what does that have that separates H from J? It has an equal to, so it should be a closed circle. What we can do with this, I know it says 4 is greater than or equal to x, we could also write that as x is less than or equal to 4, and that's going to allow me to see the direction that inequality should go because we're going to put our variable on the left-hand side. Does that make sense? A lot of people look at that and they might look at the inequality here and just go ahead and assume to the right and end up with f. Did anybody get f for an answer on that? No? Good. Okay. So hopefully we got h and we see the difference between J and H, but that's we want to look for those small details because that's the difference between getting one right and getting it wrong. Okay, it's in the details. Okay. All right, Zamira number 3. You said G? No. Okay, which of the following inequalities is represented by the shaded region below? Okay, let's see. So a couple of things we want to look at. First, what kind of line? What did you say your answer was? G. Okay. Let's see. Why am I not getting that for an answer? G. Oh, okay. So your difference there is the shading, right? It is what side of the line is being shaded on. Your line is correct, right? Because if you'll notice, my y-intercept is 1, right? So I need a y-intercept of 1. And my slope going from -1, I'm going up 1 over 1, right? Going up 1 over 1, which would give me a slope of 1, which is going to be just x. So at this point, what I have to determine is which side am I shading. Now, I don't know if you'll remember this from Algebra 2, but we have kind of a cheat. Yes, you can plug this in your graphing calculator and check it, but we can do something, pencil paper too, which is using a test plot. Because if you'll notice, 0, 0 is shaded in, right? The origin. Did anybody use the test plot 0, 0? Okay. Because we know 0, 0 works, what I can do is plug in 0 for y and 0 for x. And so what I'm getting is a relationship between essentially 0 and 1, right? Is 0 less than or greater than 1? It's less than 1. Less than, in fact, because this is not a dotted line, right? In fact, they give me all equal to. So I want 0 is less than or equal to 1. Therefore, what I want is y is less than or equal to x plus 1. That's your test plot's going to give you the right inequality symbol. Okay? Now, granted, if it had been shaded on the other side, we would have, and I know this is confusing, but we would have wanted the answer that was wrong, right? If I'm going to use 0, 0 for a test plot, I want it to not work, right? Because 0, 0 is not shaded. And sometimes that's confusing enough that what we ultimately want to use is a coordinate pair that we know is inside of the shaded region. That way I'm solving for a correct answer and I'm not solving for an incorrect answer, right? Because sometimes our brains don't flip around that way. Okay, so hopefully we see the difference now between F and G. Okay? All right, number 4. Haley, what'd you get there? A. A is correct. Okay, any questions on that? No? Yes. Yes, number 4. Okay, so notice that we have an absolute value. Wait, no, okay. This is going to be a really confusing video to watch, especially whenever you can't hear Dylan changing his mind 3 times, maybe 5 times, and just being utterly ridiculous, and then I've got to look at his face. You can't see his face, but I can.
No, I'm sorry.
And now all of this it's on YouTube, and we can all know how ridiculous Dylan is being. I'm just giving Dylan a hard time. Do you want 4 or not? No?
No, I got it.
No, he says he got it. He didn't. I know he didn't. He's lying. Okay, number 5. Let's see, Dylan. What did you get for number 5?
I got,
Remember,
yeah.
you got D? Okay, that is the correct answer. And he totally redeems himself. Okay, does anybody have a question on number 5? It'd be really funny if Dylan said that he Had a question on number 5. Wait, no, he doesn't. Yep, no. All right, let's move on. Number 6, Ryan. No. Yep. Which of the following is the solution statement for the inequality? All right, so this is gonna take some steps, but let's see. Okay. First thing we want to do is we want to simplify as much as possible. So first thing we want to do is distribute the 2. Okay. So we're going to get 4 minus what? Plus 6. Good, because that's a negative 2. All right, so we got 4 minus 2x plus 6. We could simplify that down if we wanted to. In fact, let's go ahead and do that. We're going to get negative 2x, what? Plus 10 is greater than or equal to 3x plus 1. Let's start moving things around here. What do you want to move first? Add 2x to both sides. Okay. Let's see, what do we got? And subtract 1. Subtract 1 on both sides. Okay. So that's going to give me 9 is greater than or equal to 5x. Correct? Okay. Now what? Divide by 5. Divide by 5. All right. So what I'm getting is 9/5 is greater than or equal to x. All right, now here's where we want to be careful because I actually need to flip it. And whenever I flip it, what do I need to make sure I do with the inequality? Flip the inequality as well. So I should get x is less than or equal to 9/5 c. Well, look, these two things, this essentially reads on this side. It says 9/5 is greater than or equal to x, right? X is less than or equal to 9/5. So if I move x to this side, I also have to flip the sign to go with it because I'm not changing the values of anything, right? All I'm using is the commutative property to move those things across, so the sign needs to go with it. Okay? Yep. All right. Number 7, you could not have answered this question.
Yeah, I put G.
Just put,
I put G.
and you know what? G is the right answer. I mean, if you had a graph, from my answer key, it says G is correct. So, pat yourself on the back because, hey, what did we learn? B or G it. I mean, if you don't know and you can't answer, biscuits and gravy. All right, let's see. Which of the following conditions on X determine when this will be positive? Marcus, did you get an answer on 8? No, not yet. JP, did you get an answer on 8? Okay. Let's see. When this will be positive. Let's see. I'm trying to think about this. Let's see. It should be, yeah, it is gravy. It is X when X is greater than 2. Okay. I think what we're wanting to do here is actually factor this on down. So let's see. I haven't actually got this all worked out, but which of the following conditions when X will be positive? What we can do is we can test it. Okay. So let's look at this here for a second. If X equals -2 here, right? Well, -2 minus 2, that's going to be -4. Let's do some tests. So that would be -4. -2 plus 3 is going to be 1, right? Yes. So that would be 4 times -1, which would be -4. Over here, -2 squared is going to be 4, correct? So it would be 4 minus 4, which would be 0. So I'm going to get -4 times 1, which is -4, minus 0, still going to leave me with -4. So just testing it, I can see that it can't be F, right? It can't be equal to -2. Okay? G says when x is greater than 2. Well, let's pick a number that's greater than 2. What's a number greater than 2? 3. So what's 3 minus 2? 1. Okay. And what's 3 plus 3? 6. So I'm getting 1 times 6. What's 3 squared? 9. 9 minus 4 is 5. Okay, so 1 times 6 is 6. 6 minus 5 is 1. Okay, so all of that equals 1. 0 is still kind of technically a positive number, but 1 is positive. So far what we can see is that when it is greater than 2, look at h. It says when x is greater than or equal to 10. Well, I know that that's not going to be the answer because it constrains anything below it. We already know that we already know that 3 works. So would I go with h? No, I wouldn't go with h. No, J says whenever 2x squared is greater than 10, we could divide that, and we'd end up with when x squared is greater than or equal to 5, right? And so then we'd be getting the square root of 10, or sorry, with the square root of 5, right? What's the square root of 5? 2.23. Right? Well, we already know that if the square root of 5 is 2.23, well, we already know we could probably try that. So 2.23, but let's just try 2, for instance, okay? 2 minus 2 is 0. 2 plus 3 is 5, so 0 times 5 is 0, right? So 2 squared is 4. 4 minus 4 is 0. 0 minus 0 is 0. 0 doesn't technically count as a positive number, right? So I'm not really getting anything positive there. G does come out as our answer. So if you see, you can actually throw the answers in as tests, right? And test the right answer. All right, let's look at number 9. Let's see, Vanessa, what'd you get for number 9? Didn't know. Okay. We should get no real numbers for this. Let me move this up a little bit and let's try this out. Okay. Which of the following identifies exactly those values of x that satisfy this? So the first thing I'd want to do is do what we did on Ryan's question, which is distribute the 2. Okay. So we're going to get 5 minus 2, or sorry, let's go ahead and distribute. If we're going to distribute, let's do it. Negative 2 times 3 is negative 6. And I should get positive 2x is greater than or equal to, and we can do the same thing over here, 5x minus 3x plus 3. Right? Make sure I didn't miss anything in there. We can simplify the left-hand side. We should get, with 5 minus 6, we get negative 1 plus 2x is greater than or equal to, what we get there is, looks like 2x plus 3. Okay? Well, I could add 1 to this side, right? And I could subtract 2x. Okay, well that's giving me 0 is greater than or equal to 4. Okay? Now, if that had said 0 is less than or equal to 4, I would have wound up with F as an answer because that is true. 0 is less than or equal to 4, which means no matter what I put in for x, I would get a true statement. But is 0 ever greater than or equal to 4? No, because of that, it doesn't matter what number I plug in for x, I'm always going to get an inequality that is not true. And because it's never true, there's no real number I can plug in for x that's going to give me a true statement. Okay? Therefore, it's unsolvable. Okay, does that help you out there a little bit? Okay, so anytime where my x's are going to cancel out, I should always, I hate to say always because somebody will write down in the comments section below and say, no, here's a special circumstance or something like that I hadn't thought about. But in any case that I can think of, anytime where my x's cancel out in an inequality, I'm probably going to get all real numbers or no real numbers, right? That would probably cut me down to at least a 50-50 answer, right? All right. I think we're on our last page here. Okay, let's see, number 10, Liz. J is correct. Let's see, actually pull this up so we can see it. J is correct there. Any questions on how to get J for that? No? Okay, and number 11, Zamira. B is correct. Okay, so we got all positive values less than 2. All right, should be our answer. You got all positive values. All right, so, right, 1 doesn't, yeah, and that's a good place to start. So because we've got no positive values, only positive values less than 2, only positive values between 2 and 4, only positive values greater than 4, all positive values. So the best way to eliminate all positive values is to find a positive value that doesn't work, right? So once I found a positive value that doesn't work, that's going to eliminate E. Once I find a positive value that does work, that eliminates A, and then I just have to narrow it down. So, okay, so your question was about 1, right? Well, what is 1 squared? 1. Is that less than 2 times 1? Yeah, because that's 2. What about 1 plus 2? 3. So that works, right? So we know that it's not no positive values. We know that it's not only positive values between 2 and 4 because 1 works, right? We know that it could be B, only positive values less than 2, only positive values greater than 4. So we know D isn't right because 1 works. All right. What I need to try here, it's got to be either B or E, correct? So all I have to do is try 1 more positive value. If you want to try 3, you can. So that would give me 9 is less than 6 is less than 5. Well, that's obviously not a true statement. So we know B is our answer just simply by testing. Okay? We feel pretty good about that. That should answer all our questions there. So I think we can hit stop on this recording, and you guys can check some of your other work.